started. Hello everyone. We're going to talk about IoT and cloud services. First of all, it's working. A few details about us. So about me first. So my name is Laurent Picard. As you can hear, I'm French. I live in Paris. You can follow me on Twitter with the handle Picard Paris. I work for Google in the developer relations. So it's a great job. I have the chance to talk to developers externally, but also to Google developers. My background, I'm a software engineer. And before working for Google, I forgot to tell you, I focus on Google Cloud Platform. Before that, I had my own startup, and actually I've been working for 17 years in the ebook industry. So I'm one of the 3 dinosaurs in ebooks. I made the first European ebook reader back in 1999. So I'm one of the 3 co-makers of this big machine. So it was like an iPad in 1999, 10 inches. It was big, it was 1 kilogram, but you could actually have your tablet with you everywhere. You could read on it. You could even buy and download ebooks from it. So it was launched in 2000. So as you can guess, then I created my own company called Bookeen. It's still there, it's in Paris. And as you can guess, I've been doing a lot of embedded development, so C++, a bit of mobile development because we launched Android and iOS apps, and eventually the devices got synchronized, got Wi-Fi, so we launched our own cloud, our own ecosystem to synchronize everything, the ebook readers, the apps you could buy on your mobile, an ebook, and you could read it on your ebook device. So that's my background. And up to you. So among you, who is a developer? Raising hands. So yeah, 80%. Who has already used a Raspberry Pi? 50%. Who's used another IoT device? Okay, less and less. And who's using or has used cloud services already? Oh, a lot. Okay. So I hope you will learn a few things. So as you could guess, I will first show you the Raspberry Pi just to get some background. But that's just an example. It's a perfect example of an IoT device. I'll have a quick overview of Google Cloud, but what I prefer is some action. So I'll try to do a live demo, and I hope it will work. Otherwise, it will fail miserably, okay? So first of all, the Raspberry Pi. So if you don't know it, it was the first microcomputer at the size of a credit card. So it's a small device. I have a few here just in case, but one should be enough. It has been tremendously successful. They've sold up to date 19 million units. The last one, the Raspberry Pi 3, being the most successful. They actually launched a new one. It's the latest iteration. So the Pi 3, if you remember your maths, so they launched it on March the 14th. So it was Pi is 3.14 something. So it's only, why is it successful? Because it's cheap and it works really great. It has Wi-Fi and Bluetooth embedded, and the cost is only 35 euros, so, or dollars, shipping included. So this is really something, even for kids or for professionals, you can start working on. You can get it anywhere. There are many alternatives, small ones, bigger ones, less expensive, more expensive. You can find some that cost $200 or $300. It depends on your needs. The Raspberry Pi is really the nice spot among all those offers. Okay, I've chosen also a rainbow hat. So a rainbow hat is a small accessory that you can find almost anywhere. A nice site is Adafruit. It's made by a similar company also based in the UK. I forgot to say Raspberry is based in the UK. So this little board is called a hat because you put it on top of the Raspberry Pi, and it has a small inputs and outputs. So for the outputs, you have a few segmented displays, you have LEDs, you have a piezo buzzer, and you have also a few inputs, capacitive buttons, but, and this is what I wanted, the temperature and pressure sensor just in the middle. Okay. So quickly, if you have not met Google Cloud Platform yet, as you can see, we do love blue hexagons. I love blue, so it's okay. And France is an hexagon, so it's not related, but just to mention. So there are over 70 different solutions, just to give you an idea, everything related to computing. So if you want to compute something in the cloud, everything related to big data, so if you have massive amounts of data, storage, databases, machine learning, which is very huge and growing, everything related to security, identity, IoT also. So I'm not going to really talk about this part today, but just mentioning it at the end. And everything related to development, so developer tools, development processes, and everything related to networking, of course. If you have a big infrastructure in the cloud, then you will need to handle networking. Okay, let's get some action. So I'm going to do a live demo. So I hope everything will be fine. Some things might fail because this is live. It also relies on the Wi-Fi. I make you this premise. No servers will be harmed. So it's my little joke, but it's just to talk about the serverless that maybe you've heard, maybe you know or have heard in other sessions today. This is a really pretty cool paradigm where you can actually focus on what you're doing and use services that others are managing for you. So serverless doesn't mean it's not running on servers. It is running on servers, but it means that you do not have to take care of the server configuration. You just have to focus on what you like, and I'm going to show that to you in this live demo. So this is fully managed, secured here by Google, but you know the other ones, and it's very, very efficient. It scales, and also, so if you have 10 users or 1 million users, you do not really have to change much things. It will scale automatically. And also you pay for what you use, so that's pretty cool. You don't have to pay for something that is not used, because if it's not used, you don't pay. Okay, so that's the serverless paradigm. But likewise, a Raspberry Pi might be harmed during this demo, so I will not damage anything on purpose, but it occurred to me in the past that something just failed, and I had to switch, especially cables, as we're traveling, sometimes stuff gets damaged. So this is related to embedded development in general. I have spare parts because anything can get damaged and fail. Okay, so quickly I will explain how we can do everything from scratch. So with the Raspberry Pi, usually you get a micro SD card when you order it. The OS is, so everything is on this micro SD card, but you can actually start from scratch. Take a small micro SD card and just format it and start from zero. So it takes 5 minutes. You format the SD card, you download noobs. So I will publish the slides tomorrow, so if you're interested. And you format it, you copy some system files, and then when the Raspberry Pi starts, everything will get installed. So you just need a 1 gigabyte SD card, and the OS files are just 1.7 gigabytes. And then you insert the micro SD card, you power your Raspberry Pi, and everything will get installed. It takes 12 minutes, so I will spare that for you. The OS that is on it is Linux, of course, and this is a Debian distribution. So they call it Raspbian, okay, because everything is ready, all the drivers are there for the Raspberry. When you start working with IoT devices, you have several choices regarding your development environment. So you can work with a monitor. So in a desktop mode, you can actually use the Debian desktop. But in this case, you will need a display, a mouse, a keyboard. At the opposite, you can work in a headless mode. So this is what I've chosen. I didn't want to do too much complicated things. I have my laptop and that's it. So this is the mode that I'm going to use. There's a mixed mode where you can actually use the desktop that is on the Raspberry from your own laptop. This is called a remote desktop. So you can. I guess you've seen that with other OSs. There's one thing. So here you've seen a screenshot from my laptop. Before going headless on the Raspberry Pi, there's one thing you have to make sure is to enable SSH and serial. They are disabled by default, but if you want to have your hands on this little gear, then you need to enable that. And for that, so this is the only screenshot that you will see that is coming from the Raspberry. So you enable SSH and serial, you shut down the device, and then you are headless, and you can go on. This is my choice, of course, but if you have the space, or if you want to work in a remote desktop, then you can use the Raspberry Pi desktop, of course. So one takeaway, if you're working headless, you have no head, so basically you're blind, okay? So if you're working headless, you really need to have a serial console. Otherwise, as you know, with the Murphy's Law, it will get bad at the worst time. Okay. So for this, you can use a USB serial cable. It's only $10, and it's a very simple cable. You plug 3 cables on the Raspberry Pi and the USB on your laptop. So there are actually 4 wires, but you need only 3 of them. You need the ground. You need TX for transmission, RX for reception. You can actually power any serial device, but in the case of the Raspberry Pi, it's not a device. I will explain. So here's what I did. You can actually either plug your 3 wires directly on the Pi or directly on the rainbow hat. So as I'm using the hat, the 3 pins, ground, RX, and TX, are here, also on the rainbow hat. And then the 2 options that I mentioned, power via micro USB or via serial. So really, if you're developing seriously and using sensors and other peripherals, really make sure that you're powering your Pi or your IoT device properly. So it's not a joke, because you can actually power it with USB, but some components will fail. For instance, the Wi-Fi, anything that can get current peaks will actually fail, and sometimes silently. And so your device will stop working correctly, but you will not know why unless you check for logs and so on. So always think about having your serial cable, because this is the low-level control that you have on the device, and also always power correctly your device. Okay, so now we have our console. So as I said, it's a low-level connection. You actually have the control on your device. You could also actually, that's the way you develop bootloaders. The bootloader is the part that launches the OS, the Debian distribution here. So it's the perfect tool. The only drawback is that it's slower than SSH, but with that you will always have controls. For instance, here at the conference, I need to configure the Wi-Fi, but If I'm using SSH over Ethernet or Wi-Fi, then I need some configuration. So working with the serial console is the way to configure everything. Okay, so let me show you. So here I have a webcam and I have a Raspberry Pi. So it is here powered by a proper power supply. So I try to stand by what I say. And here you have the three, so ground, reception, and transmission. And I'm not using the WEDRAN, which is the power coming from USB. Okay. And here on the right, I have my console. Okay. So let's go on. So once you're there, you can customize the device. So you, of course, change your password if you're using it in a network. You can set up your host name. So I used Asimov. Asimov was actually the name of the first server I had in 2000. You can change the prompt, the aliases, and one thing you have to do additionally, beside enabling SSH and serial before, is enable SPI and I2C. So those are buses, communication buses, and they are useful for the Rainbow Hat. And without that, it will be unable to communicate. Why customize the device? So it's nice, it's a comfort, but it will save you time little by little. So it's a cool thing. Okay, then you can configure network, Ethernet. So I will publish this slide too, so I will pass on. So it will depend on if you're doing that at home. Of course, it's a simple configuration. So you can give a name to your device and then find it by name rather than by IP. But if you're doing it in your enterprise, then it might get more complicated. Okay. Once you have a network connection, you can do SSH. So it's exactly like the serial console here. I have my console, but with the network connection, the advantage is that it's faster. One drawback is that it's faster, but it only works once the OS has started. So if you have an issue with your OS, you have changed something and it's failing upon start, then you cannot use SSH anymore. But you have your serial cable, so everything is okay. Okay. One thing also to check out is your device up to date? So I published yesterday a tweet saying everything is up to date. So it's pretty important. It will save you time. So here, for instance, the command to update the system is pretty easy. So it's an apt get update and upgrade. It takes 3 minutes, but you will make sure everything is up to date. And that's another takeaway. Take a coffee, take a 3-minute pause. It might save you hours later on. Okay? So like Ethernet, you can configure Wi-Fi. So here's an example of what I did here. So I defined a country for Singapore. I defined the Wi-Fi that is running here. So this is not this one, of course. I just reconfigured the WPS applicant. So this is the manager for Wi-Fi connections. And it works. And I hope it will keep working. Yeah, so this is not the case anymore, but just for the records, 6 months ago I had issues with Wi-Fi on the Raspberry Pi. So that's pretty weird because it has been used by millions of people and developers for sure. And after some time, the Wi-Fi just stopped working. The Wi-Fi froze. So I discovered that it was due to a bug in a driver and related to power management. So the fix was to disable power management. Okay, just for the records. You shouldn't need something like that. But if you have an issue, internet is your friend, and most of the time you will find someone who's had the same issue. So now we have a device fully up to date, ready to work. So it's time for development. The cool thing is that you have many development environments already set up, so you can develop in C, C++, in Java, Node.js, Python, Ruby, and many more. For instance, for my kids, they can actually develop in Scratch, so that's pretty cool. And also, so I'm going to show you most of the stuff in Python because I like it, and it's very easy to show with very few lines. The cool thing also is that you have a few Python packages pre-installed, NumPy, Flask, Jinja. So if you want to do a web server on your Pi, you can actually do it with Flask and Jinja in Python. But also you have the Rainbow Hat and GPIO packages that are needed to actually run this little gadget. Okay, so everything is set up. I had actually nothing to install for this demo for Python. So now, how can I put my code on the Pi? So there are many solutions. One I used is SFTP. So it's a secure FTP. So the thing you need is to, of course, get the IP of your Pi. And here I'm using VS Code as that's one of the options. And with VS Code, just install the SFTP package, configure the SFTP like this, and then every time I save my code, it gets uploaded to the Pi. So this is as if I was developing on the Pi directly. Okay, so now let's have a look at the Rainbow Hat. So every time you will have a small sample to show you how you can control the input or the output of this little peripheral. So as you can see, it's always the same. You import a package from Rainbow Hat, import display. So in Java or other languages, it will be the same. You're using a package, you're using an interface to the device. And here you can control actually anything. You can write characters, so let's write. Okay, I'm moving that. Yeah, can you see? Yeah. So I have a few aliases. So I'm going to launch the first one. Oh, I'm not at the right app. Okay. Yeah. So this is the exact sample that is in the slide. So here I'm just controlling differently the different segments here. It's random, huh? Okay. And if I stop, like an exception, I write the answer to the universe, if you can read it. Okay, so you see this is very simple, a few lines, and then you can print out something on this little display. Next, you have a few LEDs, so it's exactly the same. You import the Rainbow class, actually, and then you can control each LED individually, change the color, the brightness, or whatever. So here I'm just cycling through the different colors. It's very bright, okay. Okay. So maybe you can think about doing some sensor device with an alert system. Oh, you've got new mail or something like that. So next, you have a piezo buzzer to do music, but so I will not show you it, actually do it for you. It's very low, you wouldn't hear anything. So I don't know what they did that, it's almost unhearable, but it's there. But if you want to do music, so choose a different gadget and maybe a sound card or something to output the sound properly, okay? So I will pass on that. You have a few capacitive buttons, so it's pretty important if you want to control it with your hands. So here, pretty easy too. You import touch, lights also. You have a small LED with each capacitive button, and those are the routines I wrote just to say, okay, you've pressed the button or released the button. Sorry. So I don't want to show the music part. Okay. So here, I'm pressing. You see, it's pressed. I light up the small LED, and likewise for the other ones. So you can actually get exactly the status of each button. Next, so now another input, and this is the one I wanted initially. So right in the middle of this little board, you have a pressure and temperature sensor. And the way to retrieve the information is pretty simple. You import the weather object, and you can query the pressure and the temperature. So let's check out what we have here. So regarding the pressure, I won't be able to tell you whether it's normal or not. It looks like so. But for the temperature, 39 degrees. So this is the actual input I get from the sensor. So something is weird, right? So it's pretty easy to explain. So the sensor is right in the middle of this little board, and what is below that? The CPU. So the temperature sensor is getting heat from the CPU, and actually with the LEDs around, the LEDs are emitting some heat too. So the temperature sensor is getting heat from everywhere. So let's say it's not very precise, okay? So another takeaway for you, and I'm sorry I will have to do this impression for the talk, sensors to scale, calibrate you will. So this is, I'm sorry, my Yoda impersonation. So this, by experience, every time you will work with sensors, inputs or even outputs, you will have to deal with calibration somehow. I've had that with touch screens, even with displays. And here you can see with a simple temperature sensor, it doesn't work out of the box. So here's a workaround. So you can actually get the CPU temperature. I guess it's pretty standard in Linux. So here in Python, I'm getting it from this system file. And I'm trying to subtract some CPU temperature to the actual sensor temperature. And let's check out whether it's better or not. So I had to do a few tries. I think I subtracted, yeah, it's worse. So, oh, sorry, thank you. So here, I still have 39 something for the hat. The CPU is at 48, so this is Celsius degrees. And my calibrated temperature is 28. This is still too high, I guess. We are rather around 22 maybe, or even less. So it still doesn't work. It's still not precise enough. But this is due to the design of this board, right? So I'm not expecting to get something very precise. Another workaround would be to deport the board with a wire to take it away from the CPU. It will be better, but still I wouldn't have to use the LEDs, right? Because they would emit heat, and maybe I will get 1 degree higher. But anyway, I have my device. I can develop on it, and I have my sensor metrics. So now, how do I get these metrics? So one thing with the cloud is that you can actually have very easily a metrics warehouse, a data warehouse. And that way, you can actually check the data from anywhere in the world. Well, let's imagine that my device is at home, right? And there are many solutions for that. One of them is using BigQuery. So this is here what I call a metrics warehouse. but this is actually a big data tool where you can stream or you can push terabytes of data very quickly, and you can query them very quickly too after that. So before streaming, what I did is prepare the code for streaming. So we are not really talking about a database. It's a data warehouse. It's a bit like a NoSQL database, but we're still reasoning. We still have the raw, the table, the dataset table and row paradigm. So it means we're still reasoning with rows and columns. So here, the thing I did with the previous sample is that I organized my metrics in a row fashion. And my loop now is just getting the metrics and adding them to a list of rows. Okay, so I prepared the code because I know that I want to push my data in the cloud with rows. Okay, so let's check. And what am I doing here? I am retrieving every second. I am retrieving new data and displaying it. I display that in the console. So that's okay. So okay, it works. So here the log I have is the calibrated temperature, the pressure. I added a timestamp. So it's pretty important if I want to know when the measure was taken. For everything that is event-based, it will be important. I'm pretty sure you've met many use cases with timestamps. And here, this is the name of my little device. I told you it's called Asimov. So it works. Okay, good. So now it's ready to stream metrics. What can I do? So first of all, with cloud services, you work in a project-based way. So I created a new project called Voxxed Days Singapore with a project ID. So, and with that, I'm able to create many new services on this project. So I wanted to do it on the Raspberry Pi. So I installed the Google Cloud SDK on the Pi. So this is the way to do it. It takes 2 minutes. So it's okay, 2 minutes, almost time here for another coffee. It gets updated every week. So there are many new services or fixes or enrichments. So yeah, I could run the update. This one, I could run it every week actually. And then I initialize the environment on the Pi with gcloud init. That's it takes 3 minutes. So it will validate. You will need a browser. You will need to copy paste something in a browser, a bit like OAuth if you know it works. Okay, and then the tool I want to use is BigQuery. So I need to have the library on the Pi. And it takes also 2 minutes and just this little command. So this is the Python way of installing packages, but you could do it with NPM and anything depending on your language. And so here, so it does install a few packages, Cloud Core, Cloud BigQuery. And then I have everything ready on the device to actually talk to BigQuery in the cloud. So we are almost ready, but we don't have a table, right? We don't have a data set. So here is the code to actually create a data set and or a table. So it will always be the same. You import the right package. So here I import BigQuery from Google Cloud. If the table is not there, I will create it. So here I define a schema, timestamps, device, pressure, and the different temperatures. So you see it's very easy to define the schema. And then I just check whether the data set, is there and whether the table is there. And if it's not there, I create it. So normally before the talk, I erased everything. So it should create them. Let's check out. So it might take a couple of seconds to actually query the BigQuery the first time. But it should first create the dataset because it's not there, and then the table I want to use for the Raspberry Pi. So everything looks longer when you're doing a live demo. Yeah, it was. So as you could see, it has created a Raspberry dataset. So it's just a dataset and the metrics table with the schema that I've mentioned. So let's have a look here. If I refresh my Cloud Console, I have a BigQuery here. So let me do it bigger. So I have my Raspberry dataset and my metrics table, and I can find the schema. So as you can, if you remember, the table was created by the Raspberry Pi. Okay, I didn't have to do anything in the cloud. I actually centralized everything in this routine. If the table is not there, it's going to be created. And as you can see, the table is empty. So now, let's push the metrics to the cloud. So the only thing I have to do actually is, as I prepared everything row by row, I just have to push it to the BigQuery. And for that, you just need to create a client, so BigQuery client. You get the table, so if it's not there, it will be created just like before. And here, I decided not to push the data every second, but let's say roughly every 5 seconds. So if I have more than 5 rows, so 5 samples of metrics, I will push them to the cloud. And the only thing that is needed is insert rows, client.insert rows. This is exactly the same code. I just have added a few lines. So let's do it. So this time, the dataset and the table are there. So it's not going to create them, just checking that they're here. And then every second, it's going to take new metrics. Yeah, it's OK. And every 5 seconds, it's going to push everything that's available to the cloud. Okay, and now the device can be running in my home. I can check out what's there in BigQuery. Okay. So if I ask for, there's no record. If I check out the details, okay. Yeah, I have a refresh button. Yeah, as you can see, there are some streaming data. So this is the mechanism. Actually, there are 2 parts. Either you are batching data all at once, or you are streaming data. And the streaming data will get actually committed a bit later. But it doesn't matter. What I want to do is I want to be able to query, to check out my data. And I can do it live in real time, whatever the state of BigQuery is. So let's query the table. So here I have a sample query. So it's just like SQL now. So I'm going to ask everything. And here I could have terabytes of data. The result would be the same. You get a result in a couple of seconds. Of course, if the query is complex, it will take more time. And here, okay, I can find the metrics that have been that are uploaded, and it's just still going on, right? And then I can query the minimum. Oops. Okay. Let's get the minimum CPU temperature. Okay, as min. And then at the same time, the maximum. This is also a way to monitor my device by checking the CPU temperature. Okay. Okay, it's been running between 49 and 51 degrees. Okay, but over months it could be quite different. So then you can do whatever the queries you wish. And the data are still streaming live, right? So and I could have millions of devices, it would be exactly the same. I could query my data warehouse in real time. So let's stop it and try to do something more. Yeah, more. Here we saw that we could actually stream data from home, for instance, and query from anywhere else. But if I want to control my device and I'm not at home, how can I do? So we could imagine many different solutions, and most of the time quite complex ones, opening ports and having live sockets and everything. I thought about something that I learned actually last year. I wasn't aware of that. There's a paradigm called PubSub. Actually, I knew about RabbitMQ that I had been using with my team before. But PubSub is actually a general paradigm. So who knows PubSub? Okay, very great. So PubSub, pub is for publisher, sub is for subscriber. And in between, you have a message queue. So the publishers create topics. The subscribers subscribe to any topic they want. And the publishers will just send the messages. And the PubSub mechanism makes sure that the subscribers will get the messages. Even if the subscribers can die, can reboot, can come back to life, they will get the message. The general rule of thumb, is that the messages will be kept for 1 week. And PubSub makes sure that the subscriber will get the message. So this is pretty cool. So here I'm going to use it in a very simple way to send commands to the Pi. Okay, so like before, I'm using the PubSub package. So I'm just getting to install the PubSub package here. How much time does it? It takes 1 minute, less and less because you have less dependencies. I enabled the PubSub API. Everything in the cloud is API based. So an API allows you to actually do whatever you want with a simple REST request. But actually here, the API is wrapped up in Python or in Java or whatever, by PHP or Ruby, .NET. So you can do the actual API request, but here is very easy because everything is wrapped up. So in Python, what I do is I create a publisher client. Okay, I need a path for that. So here I used, so I'm still using my project ID, and I'm using a topic, so RPI command. And here I create the topic. If it's already there, then I will get an exception, but this is the way in Python to do it in a couple of lines. So let's create a publisher topic from the Pi. What is number 10? Okay. So again, it's going to take a couple of seconds or a few seconds. So it should create the topic because it's not there still. Okay, the topic is created. Of course, if it's already there, it's slightly faster. So I have a topic to receive the commands, not to receive the commands. I have a topic where any publisher can publish, so actually send a command. So now on the Raspberry Pi side, how do I receive the command? So I just need to create a subscription. And it's the same. So here I create a subscriber client. I still need to have my topic path and here a subscription path. For the subscription path, I'm using the host name. So only Asimov will receive the command on this subscription. And likewise, I create a subscription. And the way to receive the messages is via a callback. Here I subscribe and give a callback. And here is where I will receive my commands. One thing you have to know that is very specific to PubSub, we guarantee that you will receive the message somehow. So if the Pi is out and rebooting, after the Wi-Fi is back on, it will get the message. But you know, if we have millions of devices and things can be a bit more complex than that, a message could be delivered twice. So this is something you have to know, and also the message can be delivered out of order. So here I'm just using a global last timestamp to ignore older messages. Okay, I'm just advancing my timestamp. And here the code is pretty simple. Every time I receive a command, I will print it out. Okay, so let's create the subscription. And once it's done, it will wait for messages. So it's always a few seconds, and especially because the subscription is not there. Okay, so it has subscribed, and now it's waiting for messages. So, of course, I could control my device from anywhere, from my laptop, my mobile phone. Here I'm going to show you how to send message from the Cloud Console. Okay. But you can actually do it programmatically. So here's the topic, created RPI command by the Pi. And as a publisher, I can send a message, okay? So I publish my message, but it could actually, here it is a simple text, but it could actually be a full JSON object, or you can work with metadata if you prefer. And as you can see here, the message is there. So I have a special message to stop everything. It's stop, okay. And it should, okay, stop everything. Cool. Okay, let's move on. So now we have a way to control the device. Another use case, so my device is generating a lot of data, but could be generating many files or big files. And if anything crashes, I might lose my data. So what is the solution? I could actually store all those files on an external drive, but still, if it catches fire, then I'm lost. My data are lost. So one thing I imagine is to actually push everything to the cloud too. And this time you can simply use cloud storage. So it's just like, you know, drives. Many providers provide you brand drive, something. So here it's a cloud storage. It's like a folder that is in the cloud where you can push your data. So likewise, install cloud storage package, 30 seconds this time. And the code is very simple. So I have a storage client. I look up the bucket to check whether it's there or not. If it's not there, I create it. So I created, my demo, I created everything in Europe because I work there. But you can do it in the US or you can do it in Asia. And in Asia, you can, moreover, define exactly the region that you want. Tokyo, I don't know if Singapore, should have checked that. That's that. And then here I'm working with a blob, but what I'm doing, so I'm defining a file that is remote, but I'm actually here uploading a local file to this remote file. And then I'm doing the opposite. I'm getting back the file that I uploaded to the Pi, just for testing purposes. And the file that I'm sending is actually this code, okay? Number 12.
Yes, Singapore is a region.
So, yeah, thanks. We have a microcluster in Singapore, but I don't know if all services are available. So here it's been using a bucket called VD Singapore Media. So it's like a folder in the cloud. It's been uploading itself, so the Python code itself, and downloaded it back. So let's check in cloud storage how it looks. So here I see my bucket, so like a folder. And inside it, I have my text file. I call it .txt just for the browser to show it like that. So you see this is the actual code. And it got downloaded back. So I call it 00, yeah. So I have my copy here. I'm doing it again. No, I just wanted to show you the code. So you see, it's very easy to either upload or download files, but those are files that will be maintained. So it's once again a serverless service. So now I can make sure I have everything secured. I can control the device. I can get my data. And it will be a very secure process. So it's been pretty simple, but a bit like a gadget solution. In real life, it's a bit more complicated than that, right? So let's try something. Let's try to capture a video stream from a USB camera. Okay, so for that, it's the same. So I found a package called OpenCV. You can install it, and then the code is still very simple. You can create a CV. You can get a video capture object. If the cam is there, then it will just get a capture. So I'm not going to take a video, but just a picture. Do you remember what I said about calibration? Here I had the same issue. A camera is actually a sensor, and the calibration issue with the camera is the focus, right? So if I want to get the right picture, I need autofocus to work. So here, to keep the code simple, I just skipped the first frames to give time for the camera to be focused, right? But it's the same calibration issue. It could be the same for colors or whatever. So I have here a webcam, right? Let's take a picture of the audience. I just reverse it. Okay, let's try it here. I will take a few pictures. Yeah, I want to check. Okay, so here it's on my laptop. I unplug it and plug it on the Pi. It's a standard webcam, so actually it will work out of the box. So in the slide I explained how you can check. No, it's elsewhere. Okay, and now let's check if it works. So this is this little code, right? Yeah, so here the LED is on, you see, autofocus, taking photo and saving the picture. And here I have my picture here. So I called it photo 40 because I skipped 40 frames. Okay, so here I'm able to take a picture from a webcam. So we've done different things. Does it work all together? Let's check out. So I combine all the routines, actually without rewriting them. So it's about 300 lines, so not that much. It's actually something you can write, let's say, in 2 hours. And let's check whether, the only thing I'm going to do additionally is to upload the picture to the cloud. Okay. So I'm going to wait for PubSub to be on, the subscription. Yeah, so it has subscribed. So now it's ready to receive commands, and I'm going to, it's at home. I got some notification, and I'm at work. So I'm going to send a command and say, okay, please take a picture. So I send this message, photo, and smile. Yeah, so it's taking the picture, and now it's uploading the picture. it's written upload on my Pi. And if everything is correct, we will see the picture in the bucket here where we got our Python. Yeah. So it took a picture from my home, and the picture is now in the cloud. Very easy. So I'm going to do it a second time to have as many people as possible. So, okay, I send photo again. It's focusing, smile, yeah, uploading the picture. So it's it's faster than what uploading. Yeah, it's done now. Oh, yeah, I forgot something. It's overwritten, so I'm a bit dummy. Okay, so we've seen, so it works. I'm sorry I won't have the whole audience, but something more. I regularly update my code, but how can I update the code on my device? So there are many different ways. But here, for instance, what I did is I'm uploading a picture, and maybe I want to do something on the picture. And then you might think about microservices or about cloud functions. So actually push code onto the cloud instead of onto the device. And this is so the last mechanism I wanted to show you. You can actually trigger code in the cloud with cloud functions. It's called lambdas elsewhere. And here what I define is every time a picture or a file is there, then it will trigger a cloud function. And so I use machine learning for the function. And let's see whether it works or not. So what I did is I used machine learning to recognize faces in the picture. And if it worked, then it will have cropped all the different faces. Yeah, so it's very blurred, I'm sorry. It's because the autofocus was not enough. But Chris, you can actually, you're the first in line, you can actually recognize yourself, I guess. Okay? So sorry for the blurriness, but we have Gabe too. So actually, so it was the second picture maybe that was overwritten, but Chris was still there. Okay, so it works. So, but this is actual Node.js Python that I have pushed to the cloud. Okay, and very few lines. Okay, so it's time to just a couple of questions. Does it scale? Yeah, of course, everything that we've been using here is scalable. So those are serverless solutions. So if you have dozens of devices or millions of devices, it will work the same. If I have dozens of Pi, it will work the same. For millions of devices, so if I'm creating a successful startup, then I can use these tools. They are perfect, but I have to think about the manufacturing process. And then maybe I will need something like Cloud IoT Core to define the serial numbers and so on. But everything else can be still used that way. Okay, so time to wrap up. I'm hopefully not too late. We've seen many things from scratch. You can do everything from scratch. You can build your own device, whether at home or at work. And think about using cloud services because they are very easy to use, very powerful. They can save you a lot of time. And you can do sometimes magic with them. That's going to be it for me. I'm pretty new to Speaks, so if you want to send me feedback, please use this form, feedback-VDS. And if you want to follow me on Twitter, Picard Paris. I hope you learn a few tricks, and thanks a lot for having me. Thank you.